All right, here we are. Let's give this one a whirl. We're gonna have to convert things to meters. I started this earlier and said we may not have to convert to meters, but here's the center. Here's the force of the book pushing down on the arm here. Here's the weight of the arm, the forearm. We're just kind of combining everything at the center of mass here, and we want to find this guy right here. The force in this muscle. All right, and then here's the force on the elbow. We're probably going to have to do a couple things here. One is we probably want to go ahead and use the force on the elbow part. We're just going to use that as our torque, as our center for the torque, and we won't need to figure that into our torque equation, because I think we'll already have everything we need to find the force on the bicep. All right, that the bicep's holding up this thing. Now, and then once we find the force on then we could just move our pivot point over here to the force on the bicep if we wanted to find out what the force exerted on the elbow is being right here. Okay? All right, so let's do this. So we've got R1, R2, yes. And we're going to use this as our pivot point. So this force it's in the sum of the forces though. We have to include it in the sum of the forces. But I think just with the torque equation, we're going to be able to solve this problem without any trouble. Okay? All right, so we're just going to look at the sum, and it's not spinning, it's stationary, so everything should hold up. All right, so let me draw mine real quick here, and then we will get started. I probably should have drawn this before we got started. Well, let's turn it into a board. 4 kilograms coming down here. 4 kilograms times 9.8 coming down there. 2.5 kilograms here. And then we've got the force on the bicep going up here, F of B, which is what we're after. We got F of V coming down right here. This is 0.04 meters. From there to there. From here to here. From here to here. This is 0.16 meters. To the center of gravity. And then last but not least, 0.38 meters for that one. All right, let me show you what I've got here. Here's what I've drawn. And we've got to find F of B. Okay? So here we go. Sum of the forces, they're all in the y direction, is equal to 0. And we've got minus the elbow force plus F of B force, the force which is what we're after, minus 2.5 times 9.8 minus 4 times 9.8. Those are our forces. Those are our forces, all right? And now, some of our torques are equal to 0. But since we're using FE, this point, we don't have to calculate the FE torque. Now, let's see which one. This torque is curling back this way towards the pivot point. And so that's going counterclockwise. So that's positive. That's a positive torque. This one's going clockwise, negative torque. This one's going clockwise, negative torque. Okay, so we've done that. So now, and we got numbers. We got numbers for everything. So we've got 0.04 times F of B plus minus 2.5 times 9.8 times 0.16 minus 4 times 9.8 times 0.38. We'll move all those to the other side, divide by 0.04. And I get 0.04 times F of B is equal to, and I'm sliding these guys over to here. Let's do 2.5. Let me just calculate what those are whole-wise. 2.5 times 9.8 times 0.16 plus is equal to 3.92 newtons. 4 times, or torques, meter newtons. 4 times 9.8 times 0.38 14.9 newtons, meter newtons. Okay, so I take 3.92 plus 14.9 . 3.92 equals 18.82. 0.04 F of B is equal to that. So the force in the bicep is equal to 18.82 divided by 0.04. 470 newtons. That's a lot. That's it. That's we actually agree on that answer. So you see how these problems work? See how these problems work? All right. Cool. I think you got it. Out here.